So hi, good night. I just want to prompt you all from the very beginning. If you hear a lot of noise, it's probably this little guy here because he likes to play with paper a lot. So say hello. Alright, anyway, come on. If you hear him meowing in the back, that's his name is Tiger. Okay, so this question here goes out to Karishma, who requested it. The entire class actually. For all of you who wanted some further help with vectors and matrices, you can play this video at your own pace. You can pause it when you're home. So the first question we are going to address is the matrix question. I just printed out one I found on the internet. I think this one is 2014, June. It is one of the older CXC past paper questions, and it's pretty short. I hope you all can see it clearly, and the reason I printed it out is so that you could see the wording of the question, how it's laid out, and how they expect you to break down that into answering the question eventually. So let's go. So the first part of the question goes like this: the matrix M. Now sometimes they're not going to label the matrix using a letter. They're just going to give you a matrix like this. And sometimes they label it and they call it M, A, B. It doesn't matter, right? The point is, this is a normal 2x2 matrix, 2 rows, 2 columns. And the question goes like this: to determine the value of P for which the matrix M does not have an inverse. Only goes for 2 marks, so that should tell you the little bit of working that needs to go into answering this question. First of all, P is that's A, B, C, D. It's any C location of the matrix. It doesn't really matter, but the point is the question wants a value, a numerical value for P, right? In order to get that value, they actually give you a hint, which some of you all may read as even more confusing, but it's actually a hint. They said they want a value for P when the matrix does not have an inverse. Now, remember, in order to find an inverse of a matrix, first of all, you need to find something called the, let me see if I could write kind of big here. You need to find the determinant, and since this matrix is called M, you will be finding the determinant of M. And the formula for the determinant of a matrix is AD minus BC, right? Now, let's go ahead and find the determinant for this matrix M here. Now, the matrix is 7, 2p minus 1. And if you remember, every matrix is in the format A, B, C, D. So in this case, A is 7. So we're going to be doing a bit of substitution here. A is 7. D is -1. B is 2. And C is P, the number we want to find out. Now, when you do your calculations here, straightforward. 7 multiplied by -1 is -7. And 2 multiplied by P is 2P, minus sign here. Turns out to be 7 minus 2P. Now, when you're finding the inverse of a matrix, remember the formula goes like this: 1 over the determinant, and then you have the point where you switch these two letters. So D comes here, A comes here, and you change the signs of B and C. So you end up getting -B and -C. Now, if this is the formula for finding the inverse of a matrix is not going to have an inverse if this value here, the determinant, is a value of 0. Because if this was 0, then you would have 1 over 0, which is infinity. Well, in maths, we'll just say we don't have an inverse in a case like that. So when the question says the matrix does not have an inverse, essentially, bit of cat here, essentially what they are saying is that the determinant is equal to 0 for it to not have an inverse. So this little algebraic expression that we just worked out here, for this matrix to not have an inverse, it's simply going to be equal to 0. Now, please keep in mind, if a matrix has an inverse, you cannot equate AD minus BC to 0. Only, and I repeat, only if the matrix does not have an inverse then you can equate AD minus BC to 0. Because obviously, you would have gotten a number otherwise. Right, so moving on, when we equate this to 0, we end up getting an equation where P is the only variable, so we just simply need to make P the subject of the formula, right? So to do so, we can carry across that negative 2P on the left-hand side. So you'll get positive 2P is equal to negative 7. See what I did there? I took this negative 2P and I carried it across the equal sign, and I left the negative 7 on the right-hand side. Right, and last step to make P the subject of the formula is just negative 7 over 2. And bam, for 2 marks, that's the value of P, right? So that's one thing about the inverse of a matrix. Also, instead of using the words does not have an inverse, it could also say a matrix is singular. When a matrix is singular, the determinant is also 0. So look out for those words. Does not have an inverse as singular means to equate that determinant to 0, right? All right, so that's part A. I hope y'all can see this. Okay, shifting my page. Right, moving on to part B now. They said to express the equations, two simultaneous equations, in the form AX equals B, where A, X, and B are matrices. 2 marks. Finally, should have given more marks. Oh no, it's just to express actually, not to solve anything. So if we were to express this information, let me just fold this down here, because part A is clearly not related to part B, right? Okay, nice. So we're expressing this simultaneous equation. So in the exact format, we are going to not move around any numbers, right? The variables we are dealing with are X and Y. On the right hand side, the digits that we have are 0 and 4. And finally, the big one, the matrix, the big matrix, the 2 by 2 matrix, are going to take the values 4, 2. This is a negative sign here, right here. So you need to make this negative 2 and then down below positive 3. So make sure you answer the question. They simply said to express. They never said to solve. Look at the mark scheme, 2 marks, right? So if you find for 2 marks, you're working too hard, something's wrong. Read the question again. So this is it in the form of A, X is equal to B. So when they say express it in the form AX equals B, they are simply naming each of these matrices, right? So this matrix is A, this matrix is X, and this matrix is B, right? Straightforward. Now part C moves on to the vectors, which you all kind of know how to do pretty well. I think I'll address that in a separate